Today we're going to be looking into the last part, or perhaps last method of solving binomial theorem, which is known as combination method. Combination method. So, by definition, combination method of expansion of binomial theorem helps to give the coordinate of 10 in an expansion depending on the index considered. Combination method gives the coordinate of 10 in an expansion depending on the index considered. Let's take an example and let's see how you can apply combination method to solve problem, or rather to expand terms. Let's take the popular example we usually take, which is known as what? If I have example, if I have a plus b to the power of 2, when we use general method, we add a squared plus 2ab plus b squared. When we use Pascal's triangle method, we add the same answer. Let's now apply combination method and let's see if our answer will be comparable. Alright, let's start this way. For combination method, combination is represented by C. That becomes C this way. That C will take the highest part and here becomes 0. Take note of this. Your first task is to write out C. C takes all the part and here becomes 0. Now apply the idea of Pascal's triangle that says what? A takes all the part and B is left with nothing. So this is the first task. Plus this C, put it down here. This 2 is constant. Take 2 till the end. Put this 2 down. Why? Increasing 0 by 1. I have 1. Such that applying the idea of Pascal's triangle, reduce A by 1, that becomes A. 2 minus 1 becomes 1. Increase B by 1, that is B to the power of what? 1. If you don't understand the idea that I am using here and here, which is the idea of Pascal's triangle, you can check the link on this description. I'll drop the description on this description of this video. I'll drop the link to Pascal's triangle so you can just watch it for more understanding of this. So we said 2 is constant. You take this 2 is this 2 you are seeing here. We take it throughout, right? That becomes 2 combination 0. Pascal's triangle idea. This same 2 combination increases 0 by 1. I have this. Then apply Pascal's triangle idea. I have this. Plus that same C. This 2 is constant there. This 1 becomes what? Add plus 1. This is 0 before. Plus 1 becomes 1. 1 plus 1 becomes 2. Next up, apply Pascal's triangle idea. Becomes what? A, reduce A by 1. That becomes A to the power 0. Increase B by 1. B to the power of what? 2. At this stage, you will stop when you're having 2 combination 2. 3 combination 3 for instance, or 4 combination 4, you stop at that stage. When the numbers are up and down are the same, you stop. So I have this. So next up, what do I do? Now, mathematically, what is combination? Combination can be defined as the number of ways of selecting n different objects taken out at a time. Mathematically, combination is represented with C. So, the number of ways of selecting n different objects taken out at a time is given by n combination r, such that becomes n factorial over n minus r factorial r factorial. This is the mathematical approach of combination. N factorial over n minus r factorial r factorial. So here is the idea behind it. So if I have, let's say for instance, I have 2 combination 0. I have 2 combination becomes 2. This n is this 2. That becomes 2 factorial over n is that same n is that same 2. 2 minus r is this 0. 0 factorial. Then what? R factorial. R is 0 here. 0 factorial. So what do I get? What is factorial? Factorial can be defined as the multiplication of consecutive terms in descending order such that each term differs from the previous by 1 until 1. So that becomes 2 factorial becomes what? 2 times 1 over 2 minus 0 is what? I have 2 minus 0, I have 2. That becomes 2. Then this factorial, 0 factorial becomes 1. So times 1. So mathematically, I'm having what? 2 over 2. So 2 times 1 is 2. 2 factorial is simply 2. That becomes 2 times 1 is 2. I have 1. So 2 combination 0 is what? Is 1. So to avoid all this lengthy solution, you can easily what? Press a calculator and get the answer straightforward. So let's but much more later, we want to be considering combination as a topic on its own. So we know that 2 combination 0 is what? 1. That is 1 into a squared b to power of what? 0 plus 2 combination 1. Let me show you. This is Casio FX82MX. Can you see that now? If you have this calculator, here's the idea, please. You click on, it starts 0, and a dot blinks on the screen here. Now to press 2 combination 1, that becomes, you click on your 2 displays here. Then what? Look at, there's a combination sign here. Press that combination sign. You have 2 combination. Can you see that? 2 combination. Then what? 1. 2 combination 1. That gives me 2. So you put 2 into a to the power 1, b to the power 1 plus 2 combination 2. Do I explain now? 2. Let me show you. I have 2 combination 2. I have 1. That becomes 1 into a to the power 0, b to the power 2. So solving out this, I have 1 into a squared, b to the power of 0 is 1 times 1 plus this 2 into a to the power 1 is a, b to the power 1 is b plus 1 into a to the power 0 is 1 times b to the power of that's b squared. So 1 times all this, I have a squared plus 2 times all this, I have 2ab plus 1 times I have what? B squared. Here is my answer after expansion. If you observe, this answer was what I got when I used Pascal's triangle, general method, and also combination method. Let's take one more example and end the idea of combination method. Alright, let's solve this using the idea of combination. So I'm solving a plus b to the power of 4 using the idea of what? Combination method. What do we say in our previous example? We said the first task here is to put c. Is to put c down such that the first c takes all the power and I'm left with 0 here. That's the first task. Note that that 4 is continuous and this becomes what? Increasing by 1. So now I apply the idea of Pascal's triangle. That becomes what? A to the power of 4, b to the power of what? 0. That was the first approach. Plus I have this c. This is 4 is constant. Increases by 1, I have 1. 0 plus 1 is 1. I have 1. Reduce a by 1, a to the power of 3. Abi, increase b by 1, that becomes b to the power of what? 1. I have plus that same combination to the power of 4. This is 1. Increase this becomes 2. Next up, a, reduce a by 1, a to the power of 2. Increase b by 1, b to the power of what? 2. Next up, plus I have C, this 4, increase this by 1, I have 3. Reduce A by 1, I have A to the power of 1. Increase B by 1, I have B to the power of what? 3. Next up, plus 4 combination, this is 3 by 4 by 1, I have, increase 3 by 1, I have 4. I have A to the power of 0, B to the power of 4. Reduce A by 1, I have 0. Increase B by 1, I have 4. So here's the idea. Next up, 4 combination 0. If I punch my calculator, 4 combination 0, I have 1. That is 1 into A to the power of 4 is A to the power of 4. B to the power of 0 is 1. It's off. Plus, next up, 4 combination 1. If I punch 4 combination 1, I have 4. So that is 4 into A cubed, then what? B. Plus 4 combination 2. If I punch 4 combination 2, I'll be having 6 into A squared, B squared. Right? I have this. Next up, 4 combination 3. 4 combination 3, I have 4 into A, B to the power of what? 3. And lastly, I have plus 4 combination 4 is 1 into A to the power of 0 is 1 and B to the power of 4. So I'll be having A to the power of 4 plus 4A cubed B plus 6A squared B squared plus 4AB cubed, and lastly plus B to the power of 4. Here is my answer to that question using combination method. Also, when I use Pascal's triangle and also general method, I had the same answer. So thanks for watching.